what is one of your favorite projects? Would love to understand, right from problem statement to the challenges. Where does this, solution lies today and various other facets?
So, so one of the projects that I really like that we are doing, and I don't have a big role to play in this project. I had a small role in the beginning, and then since then I've had more of a, as I would say, a managerial or a steering role, or shepherding role for the project. There are many other people in our team, especially Makran Tapaswi, who's done really seminal work in this project. But it's a very interesting. It's been a very interesting project from the beginning, where the problem statement really came from the fact that the infant mortality in India and in other countries many of the African countries is very high.
Mm,
And one of the reasons that infant mortality is high, especially, and this is especially in the first 6 weeks after birth, it's the most vulnerable time in a child's life. And it turns out that one of the reasons the mortality is high is because of lack of proper assessment, proper measurement. And the most important parameter when it comes to measurement at that age is really the weight. So you want to be able to track the weight of a child across the first 6 weeks of birth, and if 6 weeks following birth, and if there are any abnormalities in the growth curve, you want to be able to address that in order to avoid complications and eventually mortality. Uh, the problem is in many of the global south countries, the way babies are weighed in rural areas is essentially using a spring balance. At birth,
mm,
at birth they are weighed accurately. For example, in India, 80% of babies are born in a hospital, and in a hospital they are weighed accurately with a digital weighing scale. Um, but once they go home, once they go back to their villages, uh, uh, they are essentially tracked by ASHA workers who go door to door and weigh the baby with a sort of spring balance. And you can imagine the errors involved in this process. The spring balances
mm,
are not well calibrated. It's very difficult. There's a huge infrastructure problem associated with this. The baby's weight is eyeballed and then written on a register. This is another source of error. Sometimes what happens is that the weight is rounded up because if, for example, the WHO standard for baby weight in the first 6 weeks is 2.5 kg. So if it goes below that, there are lots of interventions to be taken. ASHA workers don't necessarily have the bandwidth to take these interventions. So often the weight tends to be rounded up a little bit. So all of these issues are there with the current system. And uh, this was brought to us by the Gates Foundation, and we started thinking of an AI means of working on this problem. And one of the things, so the way we started attacking it was using a computer vision AI method, where we take a video of the baby in their home setting, and from the video infer the weight. And the video is necessary in order to get some sort of 3D understanding of the baby. So it's an arc. You use a basic smartphone that is anyway given to the ASHA workers by the government, and then you use the camera of the smartphone to take a video in an arc over the baby. And
mm.
so that gives a sense of depth because you see different parts of the baby's surface, and that gives you an estimate of the weight. Now we had to do very tough data collection to ground truth this. We collected videos for about 30,000 babies and ground truth weights, ground truth other measurements as well, like height and head circumference and chest circumference and so on. And it was about a 4-year data collection effort. Uh, and now we've got the model working to within an error of 110 grams or so, which is very usable in the field. Average error, mean absolute error of 110 grams, which is very usable in the field. And it doesn't really require any special equipment beyond a basic smartphone and a
Mm.
wooden ruler that is put next to the baby to serve as a reference object, so that you can use this at various distances uh, without error. So this has been one of our most challenging projects. It's now rolled out. It's being used by ASHA workers and mothers in Daman and Diu, and now we're slowly hoping to roll it out across India, hopefully in many other places as well, eventually.
Wow, fantastic, fantastic. Uh, so while you guys were solving this problem, right? Once, like you said, data collection itself is a very big challenge, right?
Yes.
Because it's not just the angle and the depth. is also the lighting condition,
Yes.
what is the kid wearing, right?
Yes.
So in a lot of these cases, the conditions under which the observation is taken often becomes a source, right? So there has to be a, how are you guys ensuring that the SOP is followed by the ASHA workers? Because unless that is done, it
Yeah.
is very easy that things can go from here and there.
Yeah, so it took a lot of back and forth. The final usable data was a result of a lot of rejection that happened on the way. So we had to converge on a good protocol. We had to make sure that we didn't have to throw out data once a protocol was finalized, that the ASHA workers would actually use it. So we had guidance in the app. We created an app. We had guidance in the app to make sure that the baby remained in the frame of the video. We had to do some training of the ASHA workers. So there is a little bit of a training curve to use this properly. We initially did a lot of experiments in a hospital setting where we had sort of clean white backgrounds, good lighting, just to see if the technology could work, if there was potential, if there was enough
Sure.
information in that video to actually
Yes.
infer a weight. And then we started getting very good results in a hospital setting, and which is when we felt confident enough to go into the home setting. And there we took, for training, we took videos under various lighting conditions, different backgrounds. So there's no restriction on the kind of background cloth you put under the baby. There's reasonably no restriction on lighting conditions. Of course, it can't be completely dark, but
Okay.
it works within natural light inside village homes. So it's very robust, and that was a result of iteration on the protocol. The other issue we had was the depth estimation problem, which is a standard problem in computer vision. A well-known problem, and the standard solution to that problem is to put a checkerboard in the frame of the photograph or the video, right? And the checkerboard is fixed dimensions, just so that you can eliminate the depth variable. And so with the checkerboard, we tried, it worked well. And then we were told, see, these are some of the applied on the ground constraints that you have to be sensitive to. We were told that ASHA workers could not carry a checkerboard with them. That is something they would just not have in their arsenal.
Mhm.
So it was not a scalable or usable solution with a checkerboard. So the whole thing was dead in the water if we had relied on a checkerboard. So
Yeah.
then we started looking at other fixed dimension objects like a coin or other things, and then we converged on the simple wooden ruler that you get in every, you know, essentially every corner in India, and it's
Yeah.
very standard dimensions. So that worked very well actually.